Hi everyone. Today we're going to learn about scatter plots and then learn how to do what's called a best fit line. So let's start with the scatter plots. A scatter plot is basically a plot of a graph of just a bunch of points. And it's called a scatter plot because you're plotting points, and it may not be like a perfect line. They may be kind of scattered all around. Now, when the points tend to kind of follow a pattern, we say they have correlation. So here's some examples of three different scatter plots. Now, if you notice, the first one is kind of like right down in a row. It's not a perfect line, but you can kind of see it's going in a line. The middle one is it's kind of going like that, but it's not like it's not a nice tight line like the first one. And the third one isn't really a line at all. They're all scattered around. So what we would say the first one has strong correlation because we can definitely see a pattern there. It looks like a line. The second one has moderate correlation, which means it kind of looks like a line. I can see that it's like starting up here and decreasing, but they're spread out pretty wide. The third one I would say has weak correlation because I don't see a pattern at all. I don't see a line there at all. I just see a bunch of points scattered around. So that's what we mean when we say correlation. We say, is it just a bunch of points that I don't see any pattern at all to? That would be weak correlation. Or do we see a nice, neat pattern to them? Now, what we're going to focus on, we've been focusing a lot on linear equations or straight lines. So we're going to focus on linear correlation. We're going to be looking to see if the pattern makes a line. Now, we are going to kind of separate it here, just like we did with slope. And we're going to say the linear correlation can be positive or negative, depending on whether the line is increasing or decreasing. So here's a couple examples again. Now the first one, there's a scatter plot, and I actually drew a line through it. The second one, same thing. The third one was kind of like before. That's no real correlation. I don't see a line in there at all. So what I would say is the first graph has positive correlation because you can see the pattern of the points is a line that's increasing. It's going up, 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 up. Now the second one has negative correlation because it's decreasing, down, 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 down. And the third one, just like in our first picture from today, has no correlation at all. So just think of it like slope. When the slope of a line is positive, the line is moving up as you go from left to right. When the slope is negative, the line is moving down or decreasing from left to right. Same thing here. Okay, so the other part of the title was best fit line. That's actually what you're looking at in these first two pictures. When the scatter plot has linear correlation, you can draw the best fit line like the two below. Now, best fit line is exactly what it sounds like. It's the line that fits those points the best. Now, it may not be perfect for now. There is a way, and we're going to learn about it in 2 sections down the road in the book. There is a way to use like a calculator or a computer program to find the perfect best fit line. But for now, we're just going to draw a best fit line, what we think the best fit line is. Now, once you've drawn that line, all of a sudden it ties in to what we've been working on all chapter long or all module long. We are going to find the equation of the best fit line. And you can do it using point slope form. Just choose any 2 points and use rise over run to find the slope. And then use any point to finish the question. So let's go ahead and try that out. So for our example today, I gave you an XY table, kind of squeezed in there over on the right. We have 1, 2, 3, 4, 5, 6, 7 different points. So I said plot the points in the table, draw a best fit line, and find its equation. Now when I go to plot the points, the first thing I notice is they're all positive numbers. There's no negatives in this question. So I think what I would do, instead of doing like the plus-shaped graph that has all 4 quadrants, I would probably do a graph more like this. Like the L-shaped graph. So let me draw a better line here. the L-shaped graph that does only positive numbers. Now the second thing I want to do is I always scale my problems. I look at all the x values. The x goes from 1 to 20. So I might count by like 2's and make them relatively small. Go 2, 4, 6, 8. This would be 10, 12, 14, 16, 18. This would be 20, and that's as far as I need to get. Now the y values start at 5, and the biggest looks like 38. So I might count by 5's on the y-axis. 5, 10, 15, 20. 25, 30, 35, 40, and that'll be enough for us. So see how I use scale to make sure all my points will fit well on the graph. And now I'm going to plot the points. So let's do 1, 5 would be about here. 3, 7 over 3 up 7. 8, 20 is going to be here. 12, 21 would be about here. 13, 30. 15, let's see, 10, 15, 35 is going to be about here. And 20, 38 would be about here. Okay, might have looked a little bit better on graph paper, but that's okay. Now what I'm going to do is I'm going to draw a best fit line. Well, actually, first of all, what I see here is positive correlation. I see these are kind of line shaped and it's kind of going up to the right. So I think we do have correlation, and I think I can draw a best fit line. So what I'm going to do, I'm going to take a look at these points. And remember, you don't have to use any of the exact points. You're not like saying, I'm going to pick the first and last point and connect them or anything like that. Just as best you can, draw a line that fits the pattern of those points. So let's say that's my best fit line right there, that yellow one. I go, okay, that looks pretty good. The points are kind of around it. Some of them are a little bit below it, some of them are a little bit above it, but they're kind of all around it. And now what I want to do is pick 2 points to use for my problem. You can use actual points from the XY table, although you don't have to. If you can find a point from the XY table, like to me, I have this one right here. It's not a very good color for this one. Right here, and that was the point 3, 7. And maybe I'll use this one right here. That one was on the line. That was the point 13, 30. But remember, it doesn't have to be a point from the line. Like if I wanted to, I could go to 10 on the x-axis, pick this point and approximate, say that's about 10, 20. You can do that too, that's fine. Just pick any 2 points. I think for me, I'll go ahead and use these 2 right here, since we already had them from our XY table. So let's make a line using those 2. The first thing I need is the slope. I can do rise over run, but since I don't have graph paper, it's hard to count squares. I think I might do slope formula for this. I might do y2 minus y1 over x2 minus x1. And let's name and number our points. Let's make the 3 and the 7, that'll be my x1 and my y1. And make the 13 x2 and the 30 y2. So what I have for my slope is y2, which would be 30, minus y1, which is 7, over x2, which is 13, minus x1, which is 3. So what I get is 30 minus 7 is 23, 13 minus 3 is 10. That's it. That's my slope. It doesn't reduce. 23 and 10 don't have any numbers you can divide them by. Remember, we don't really like slope as a decimal, so leave it as a fraction. But I'm going to say that my slope is 23 over 10. Now, for the rest of the question, I actually told you earlier you can use slope-intercept form. I think I might go with point-slope form instead. Let's do y minus y1. It would work with slope-intercept form. But I think I might do this instead. So let's go ahead and stick with the same x1 and y1 we used before, which is this one down here. and I will have y minus 7, y1 is 7, equals my slope, which is 23 over 10, kind of a messy fraction, but that's okay, times x minus, and then x1 is 3. And this is why I used point slope form. I didn't really want to mess with it and have to solve for b with that messy fraction slope in there. With point slope form, you just get to plug in the numbers and you're done. So I'm going to say that's my answer. Y minus 7 equals 23 over 10 times x minus 3. And just remember, there is no one correct answer to this. If you pick different points from me to use, your answer would be different. Or even if you drew your line a little bit different. You know, maybe I thought that was the best fit line, but you thought this one right here was the best fit line. Again, that's a little hard to see, the purple, but maybe you thought this one right here was the best fit line. You know, it's not really saying one of us was right and one of us was wrong. We just saw it a little bit differently. So there isn't one correct answer to this. What I'm looking for is that you understood the process, you drew a line that looks reasonable, looks like it's a pretty good fit, and that you used 2 points from that line to write its equation.